Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Our lesson today is about generalities of transformations. Definition: a transformation is a change in the position or size of an object or point. First of all, we will talk briefly about kinds of transformation, which we will explain in details later. The first kind is the translation. As you see, translation changes the position of an object by a given vector without changing in size. Axial symmetry. This line is the axis of symmetry of these two figures, and this axis of symmetry is the perpendicular bisector of the segment M prime, where M prime is the image of M by this axis of symmetry. Rotation. In fact, in rotation we have a fixed point and we rotate the object by a constant angle without changing in size. Now dilation. As you see in dilation, the position and the size of the object will be changed. The last one is the direct plane similitude. In fact, the direct plane similitude is a rotation followed by a dilation or a dilation followed by rotation. Definition: a transformation T is a mapping from a plane P onto itself that associates to every point M in P a unique image M prime in P such that T of M is equal to M prime. Here we have a transformation T that transforms M onto M prime. In this case, M prime is called the image of M by T, and M is called the pre-image of M prime by T. Let us take an example. Let ABC be a given triangle. Let O be a given point that's located outside the triangle ABC. Let T be the transformation that associates to every point M the point M prime. This means T of M is equal to M prime such that O M prime vector equal to O M vector. Now part 1, locate A prime equal T of A and B prime equal T of B and C prime equal T of C. Now if T of A is equal to A prime, then A prime plays the role of M prime and A plays the role of M. So we put A prime instead of M prime and A instead of M. We get OA prime vector equal to OA vector. This means OA prime and A are collinear and OA prime equal to OA. In this case, A must be the midpoint of the segment A prime O. So A prime must be in this position. Now T of B is equal to B prime. So by the same way, OB prime vector is equal to OB vector. Then B is the midpoint of the segment OB prime. So B prime must be in this position. Now T of C is equal to C prime. So by the same strategy, OC prime vector is equal to OC vector. Then C is the midpoint of the segment OC prime. Then C prime must be in this position. Part 2, what do you say about the triangles ABC and A prime, B prime, C prime? In fact, if we match the triangle A prime, B prime, C prime, we notice that A prime, B prime over AB is equal to B prime, C prime over BC is equal to A prime, C prime over AC, which is equal to 2. So these two triangles are similar. Part 3, determine T of O. Now if T of O is equal to O prime, then put O prime instead of M prime and O instead of M. We get OO prime vector equal to OO vector, which is equal to 0 vector. In this case, O prime coincides with O. So we can replace O instead of O prime. We get T of O is equal to O. Application 1. Let ABC be a given triangle. Let V be a given vector. T is the transformation that associates to every point M the point M prime. This means T of M is equal to M prime such that M prime vector equal V vector. Pay attention, T of M is equal to M prime means M prime vector equal to V vector. Part 1, locate A prime equal T of A and B prime equal T of B and C prime equal T of C. Try to answer it. if T of A is equal to A prime, then AA prime vector is equal to V vector. Then AA prime vector and V vector have same sense, same direction, and same magnitude. So A prime must be in this position. Now T of B is equal to B prime, then BB prime vector is equal to V vector, and BB prime vector and V vector have same sense, same magnitude, same direction. So B prime must be in this position. By the same strategy, if T of C is equal to C prime, then CC prime vector equal to V vector, and C prime must be in this position. Part 2. What can we say about the triangles ABC and A prime, B prime, C prime? Try to answer it. If you match the triangle A prime, B prime, C prime, we notice that the two triangles ABC and A prime, B prime, C prime are congruent triangles. Definition 2. Let T be a transformation that transforms every point M onto a point M prime. That is T of M equal to M prime. Now T is an identity identical if and only if T of M is equal to M for all M belong P. T is denoted by ID. T has an invariant point or double point B if T of B is equal to B. T has an inverse transformation T minus 1 if T minus 1 of M prime is equal to M. Pay attention here. If T of M is equal to M prime, then T minus 1 of M prime is equal to M. Here we have T is a transformation that transforms M onto M prime. Then T minus 1 is a transformation that transforms M prime onto M. Definition 3. Let T and T prime be two transformations. The composite T round T prime is a transformation defined as T round T prime of M is equal to T of T prime of M. Here T prime is a transformation that takes M onto M prime, and T is a transformation that takes M prime onto M double prime. Then T round T prime is a transformation that takes M onto M double prime directly. In the other meaning, we have to find the image of M by T prime, let's say M prime, and we have to find the image of M prime by T, let's say M double prime. Then T round T prime is the transformation that takes M onto M double prime directly. Remember, T is an identity if and only if T of M is equal to M for all M belong P. T is an invariant point by T if T of B is equal to B. If T of M is equal to M prime, then T minus 1 of M prime is equal to M. T round T prime of M is equal T of T prime of M. Example 2. Let ABCD be a given quadrilateral. Let M and M prime be two variable points. T and T prime are two given transformations. Complete each of the statements below. If T of C is equal to B, then B is the image of C by T. The second one, if T of A is equal to A, then A is called an invariant point according to the second remark. If T of B is equal to C and T prime of C is equal to A, then T round T of B is equal to T prime of T of B, and since T of B is equal to C, we get T prime of C, which is equal to A. If T of M is equal to M for every M, then T is an identity or ID according to the first remark. Now, if T of D is equal to A, then T minus 1 of A is equal to D according to the third remark. If T of M is equal to M prime, then T round T minus 1 of M prime is equal to T of T minus 1 of M prime. And T minus 1 of M prime is equal to M, we get T of M, which is M prime. And T round T minus 1 is an identity or ID since T round T minus 1 of M prime is equal to M prime according to the first remark. Application 2. Let ABCD be a given quadrilateral. Let M and M prime be two variable points. T and T prime are two given transformations. Complete each of the statements below. Try to answer it. Now, if T of A is equal to C, then A is the pre-image of C by T. The second one, try to answer it. If T of D is equal to D, then D is an invariant point according to the first remark. The third one, try to answer it. If T of A is equal to D and T prime of B is equal to A, then T round T prime of B is equal to T of T prime of B, which is equal to T of A, and T of A is equal to D. Try to answer it. If T of M is equal to M prime, then T minus 1 T of M is equal to T minus 1 of T of M, which is equal to T minus 1 of M prime, since T of M is equal to M prime, and T minus 1 of M prime is equal to M. And T minus 1 round T is an identity or ID. Try to answer it. If T of B is equal to C, T of C is equal to D, and T of D is equal to B, then T3 of B is equal to T round T of B 3 times, which is equal T of T of B, and T of B is equal to C, we get T of C, and T of C is equal to D, we get T of D, which is equal to B. And B is called an invariant point, since T round T of B is equal to B according to the second remark. Example 3. In the complex plane referred to a direct orthonormal system OUV, consider the points M and M prime with respective affixes Z and Z prime such that Z prime equal to IZ plus 3 minus I. T is the transformation that transforms M onto M prime. Part 1. Let A be the point with affix ZA equal 1 plus 2I. Find the affix of A prime, the image of A by T. Now T of A is equal to A prime. A prime likes M prime and A likes M. So according to this relation, ZA prime equal to I ZA plus 3 minus I. And if we substitute ZA by 1 plus 2I, we get ZA prime equal minus 1 plus I. Part 2. Let B prime be the point with affix 1 minus I. Find the coordinates of B, the pre-image of B prime by T. Now T of B is equal to B prime by the same way ZB prime equal to I ZB plus 3 minus I. And if we substitute ZB prime by 1 minus I, we get ZB equal I. Thus, coordinates of B are 0, 1. Part 3. Find the affix of L, the invariant point of T. Now, if L is an invariant point, then T of L is equal to L. So ZL equal to IZL plus 3 minus I. And if we change to IZ before equal and take common factor ZL, we get ZL equal 3 minus I over 1 minus 2I, which is equal 1 plus I by using calculator. Thus, ZL equal 1 plus I. Application 3. In the complex plane referred to a direct orthonormal system OUV, consider the 2 points M and M prime with respective affixes Z and Z prime such that Z prime equal to Z minus 3 plus I. T is the transformation that transforms M onto M prime. Part 1. Let A be the point with affix ZA equal to I. Find the affix of C if T of A is equal to C. Try to answer it. Now, if T of A is equal to C, C likes M prime and A likes M. So according to this relation, ZC equal to ZA minus 3 plus I. And if we substitute ZA by 2I, we get ZC equal minus 3 plus 5I. Part 2. Let B be the point with affix 1 minus I. Find the coordinates of D if T of D is equal to B. Try to answer it. Now T of D is equal to B, then ZB equal to ZD minus 3 plus I. If we substitute ZB by 1 minus I, we get ZD equal 2 minus I. Thus, the coordinates of D are 2 minus 1. Part 3. Find the coordinates of the invariant point J by T. Try to answer it. Now J is an invariant point, then T of J is equal to J, then Zj equal to Zj minus 3 plus I. So Zj equal 3 minus I, thus J3 minus 1. Part 4, find the complex form of t minus 1. Try to answer it. In fact, if we want to find the complex form of t minus 1, you have to find z in terms of z prime. Then z equals z prime plus 3 minus I over 2. So we get half z prime plus 3 over 2 minus 1 over 2I, which is the complex form of t minus 1.